of these derivatives, some of the slope of the tangent line, or the equation of the tangent line, all those that you still need for your test that you have in a couple weeks. All right, so with this one, I just review up here, but they want us to find dy dx. Okay, and they give us that y is x to the fourth times cosecant x to the fifth plus the square root of x. So what is the main big thing happening here that I have to start with? Multiplication, which means what rule? Product rule. Okay, I have to start with that product rule. So we have first times the derivative of the second plus second times the derivative of the first. Okay, so I'm doing a product rule one today. I'll probably do some more quotient rule ones next week to kind of review that. So I have y prime that ends up being first times the derivative of the second. This one's the big one. Let's see if we remember what, when I do this derivative right here, remember, work from your outside in. This is where chain rule comes in now. So I have cosecant. What is the derivative of cosecant? Go ahead, John. Very close. What do you need out front of it first? A negative. But yes, it's cosecant, cotangent with a negative up front. So I have negative cosecant x, which this entire thing is your x. Cotangent x, which again is the entire thing. And then times it by our chain rule. So this is all just the derivative of this second piece. What is the derivative then of the inside part?
5x to the
5x to the fourth.
plus 1 over 2 squared x.
Yep. Some of us on the quiz mixed up that with the 1 over x derivatives. Just make sure you're trying to still memorize that square root of x derivative. And if not, you can always think of square root of x as x to 1/2. And then the power rule from there. All right, so that is first times the derivative of the second. So ultimately, this entire thing is just the derivative of the second. Plus, very long derivative, second times the derivative of the first, which is just 4. That would be yucky if you had to simplify that. Okay, the only thing that they probably would simplify here is they would combine this x to the fourth with some of these ones right here that you have multiplying. Is probably what it would, like if you looked at it in a multiple choice type question. They probably would combine the x to the fourth with these two, and then bring that 4x cubed out front. Some ways that they might organize that differently. So I would be totally fine if you left it like this and you saw on the quiz that you can leave it how it is. You can simplify, but I will take, like if you do simplify and you give me that answer, I take that answer. So even if you simplify it incorrectly, I still, then it would be marked wrong because you gave me that as your leaving it in the unsimplified. Okay, multiple choice, test no is where it's not multiple choice. Just do throw in some more multiple choice throughout the test. And let's start talking about SR2 questions. We haven't really seen any exact one like that. We'll first of those into quizzes and tests so that we can see more of that throughout the year instead of way just at the very end. So you'll see some of these sometimes having to be reduced a little bit. All right, so the main thing that we were talking about today and Monday is implicit derivatives. And so you definitely want to write down what I'll have on this whole first page on top of the example. All of these problems will be very different for the fact that you still have derivatives that you have to fit, but how you get to your answer has ways of trying to get one from derivatives. They're just going to look a little different. So implicit derivatives are used when your equation is not solved for y. So you're going to have variables x and y in these functions, and it's something where you're going to have like x squared plus 2xy squared equals 5. And to do an implicit derivative is you don't have to necessarily solve for right away at the beginning. There's going to be some times where you might here. So if I had an x, y equals 2, I could just divide by x and get y equals 2 over x. And then do my derivative. But there's going to be stuff that are just long and it's super hard to get y by itself. And then have to do the derivative. So implicit derivative is going to be a lot when you can't get y by itself. Okay, or it's not already solved for, it's a lot easier to go straight to implicit derivatives. Also, something to note with it is that every y that we're going to see today needs to have a chain rule of a y prime. Okay, so if I had the derivative of x plus 3y squared today, we're going to see that as 1 plus 6y y prime. So still do the derivative like x, still do the derivative of y, but they always will attach a y prime whenever you do the derivatives with y today. Because that's when we'll have to actually go and find our y prime. We'll end up trying to get y prime by itself at the very end. So that's what you're going to see today. That's what this black part means. It's just that you're going to have to attach a y prime whenever you're doing the derivative with y. Don't have to do it with x, because x is usually the variable that we're using throughout a function of y in terms of x. But that's why we have to attach a y prime. So these steps will be big ones to talk through, because we will do these in every example problem that we'll see today. So the steps to actually do implicit derivatives, the first thing you need to know is that each term's derivative, you need to just do your normal derivative of what you have. So that example I show you, I did the normal derivative of x, I did the normal derivative 3y squared, but then I have to attach that y prime. So do your normal derivatives, again, using power, product, chain, and I put quotient rule up there, but you might have some quotient rule. Those three, though, are probably more common with this implicit versus the quotient rule. And then gather all your y prime terms on one side. So this one only has one, but sometimes you might have something else that was saying like 2y over here. So then you'd have a 2y primes. You might have multiple y primes on one side. So you're going to gather them all on one side to try to get them by themselves. Factor out the y prime and divide the crap out of everything. So that is just the same that we use to remind us that, hey, at the very end, that last step, a lot of times is going to be dividing through all the y prime. And once I get y prime for myself, you divide out everything else. So these steps, as long as you're writing these down, these steps will help you through these examples. We'll follow these steps as we go through. The first example you'll see where maybe we'll try algebra first, and then do our cotest, and then have the actual implicit derivative work with that too. And then we'll do more that you only can use the implicit derivative because algebra will not work first. All right, so the very first one, we'll step through just algebra first on what we've normally done, and then we'll do it the implicit way. So if I want to get, do algebra first, you first need to solve for y. This one's nice and easy. Y ends up being 1 over x. A lot of times implicit derivatives are not just as simple as that. So then we know this. What is my derivative of 1 over x? It's one of the ones you have to memorize. That's the square root of x. That's the derivative of that. Negative 1 over x squared. Okay, so that's my y prime. Again, algebra, yeah, that was probably easiest for that one. But let me show you how that compares with the implicit way. The implicit way says do your derivative like normal. So this one has a product rule. Without moving anything, this one has a product rule. So I would do first times the derivative of second. What's the derivative of just y? Y prime. Ultimately, there's a 1 out prime, but you just put the y prime. So first times the derivative of the second plus second times the derivative of the first, just 1, equals, you still have to do the derivative of this side. Well, what's the derivative of 1? Just 0. So a lot of times you're going to see it equal to a number, or sometimes they might have more of the x squared over on that side too that you have to do the derivative. All right, so now I have this. Now we just have to, so the implicit way is now get y prime by itself. So clearly on this one, yes, that's probably going to be easier on that simplest, try to get y by itself. But let's just work through this. If I want to get y prime by itself, I want to move this y over first so I can get that y prime. So I get x y prime to equal a negative y. Subtracting the y over from 0. Divide by x, so I get y prime to equal a negative y over x. Now, this right here doesn't look exactly like this one,
but they are the same for the fact of what is our y? 1 over x. So if you substituted that back in, I have y prime equals a negative 1 over x all over x, which is the same thing as a negative 1 over x squared. Now it looks just like that. Okay. Clearly, though, implicit for this one, you would not want to do. You want to do algebra first. But we're going to get into ones where you're going to have to do implicit derivative. And this one just shows you that, hey, I have this. If I have a y, which this one I already had the y, so I have to plug it back in. Sometimes you might not have a y that you could have solved for, so you might not have a number to plug back in. This one I was just kind of comparing that negative 1 over x squared for a previous negative 1 over x squared. Okay, they end up having the same derivative, but this one definitely has more work in this type of problem. Okay, so still your first goal is to see if you can get y by itself, if it's easy to do so. But there's going to be problems where it's not necessarily so easy. Okay, yeah, you could here. You could end up doing some cube row work. But this one's actually going to be a lot simpler with implicit. So this one has find y prime for 2x squared minus y cubed equaling 8. So again, we're doing the derivative of each one, just making sure we're attaching that y prime when we do the derivative of that y cubed. So I have 4x minus 3y squared times the y prime equaling 0. And now just get y prime by itself.
So you don't need to put y prime on the end of every single one.
Only the y's. So whenever you have a y, so sometimes you're going to have multiple y's. So yes, you're going to have it in multiple spots. In this case, we've only had one spot that has a y, so there's only one spot that we've had the y prime. Yep. So the x does not get like an x prime because we're keeping it in terms of x. So that's why we keep the x. So I'm going to subtract the 4x over, so I get a negative 3y y prime equals a negative 4x. Divide the crap out of everything. So I get y prime to equal 4x over 3y. Now, with these ones, again, you don't have to always plug in like y back in like we did in the previous one, because up above, solving for y is not the easiest thing. Whereas the previous one, we could easily solve for y. Got the 1 over x and go plug it back in. This one, it is totally fine if you keep it as your answer of 4x over 3y. Go ahead. Okay, say that again, sorry. What were you saying?
So, it wasn't 3y squared.
Yeah. Because I subtracted the 4x over. So we're here, and our whole goal is to always try to get y prime by itself. Oh, squared, yes. Sorry, yeah, sorry. The whole point was I forgot the squared. Yeah. No, you're good. I forgot the squared. Yes, should be the 3y squared on left. Elena, does that answer your question? Okay. Yes, not forgetting that squared part. But again, you don't have to necessarily plug in y unless y was something easy that you could solve for, like the previous one. Okay, so a lot of times you're going to keep it like this as your final answer. We'll talk about second derivatives today too with these implicit ones. With second derivative, we're going to have to plug in the first derivative. So that is one thing we'll talk about at the very end today. All right, so let's try this one. So I want you to try this one on your sheet of paper. Once you have it, you think you have it done, just compare it with somebody next to you. So try this one out. This one does have y though. This one's going to involve a little bit more work because of that. So two x's on the final. Yeah, that first one you're gonna have to do product rule. The 2x minus 4.
When you do the particle of the 2x and y to the fourth, don't you have to include y1, 2 next to the y?
Y prime, you mean?
Or y prime?
Yep, next to that derivative once you do the y to the fourth derivative.
Not to when you just have like, so first 100 second plus second, so not when it's just y to the fourth. So only to when you do the derivative to do it as a y prime.
You finish it, comparison next to.
And your goal is to get y prime by itself. So this one you have to factor out a y prime. There's nothing in here. And the only thing I've written up there is the first step. So your first step is also my first step. Product rule and the derivatives of the other two. So today you will want to simplify at least a little bit. Oh, we have to do the derivative of 10, which is 0. Yeah, so even the equal side, we have to still do that derivative. Raise your hand if you got to this point.
At least this point.
Okay, second step, all I did was kind of simplify, combine some terms. What would you do, because this is the step we haven't done quite yet, what would you do at this point? Let's see. Okay, so we have these middle two that don't have y prime. So I'm going to subtract the 2y to the fourth, add the 6x. So I am getting 6x minus 2y to the fourth on this side. And I'm left with 8x y cubed y prime plus 2y y prime. Raise your hand if you have that so far. Okay, and again, we haven't done some of this where we had to get y prime. We had 2 y prime. So all we did is got everything other than the terms that had y prime. Now, if you kind of look back to the steps that you had above, what would you have to do at this step? The whole goal is to get y prime equals factor out the y prime. So factoring out a y prime, so that just means since they both have y prime, you're just writing what you have left. 8xy cubed plus 2y. And then the last step is divide the crap out of everything. Once you have y prime by itself, you're just dividing by what that y prime is being multiplied by. So I have y prime equals 6x minus 2y to the 4th. Again, you could reorder the top if you had a flip flop. And then 8xy cubed plus 2y. The top, or both top and bottom. Up to you. I wouldn't be picky about that. Multiple choice might do that. Multiple choice. So what she was saying is that since I could pull out a 2 from the top and the bottom, and then those 2's could cancel. Ultimately, yes, multiple choice probably would do that. When it comes to like a quiz or a test, I would still accept this for what you have. Okay. Any questions on how? So that was the longest one we've had so far, since we had the 2 y primes. So I still have to kind of go back to the beginning and just realize again, every time you're doing the derivative with y, you have to attach y prime. Only when you're doing the derivative. This part we did not have the derivative, y to the 4th times 2. So that's why y to the 4th is still staying. All right, so again, just getting practice with different types of derivatives with this. So this one, we have another product rule in the middle. So let's kind of work through this one. The first one, what's my derivative? And attach a y prime. That's the biggest thing with these implicit derivatives. The y prime is the biggest thing. Like that. And then minus, now I'm going to do the product rule. You could take the minus with the x squared if you wanted to. I'm just going to keep that subtraction out front and then just treat it as x squared and y when I do the product here. So I have first times the derivative of the second. Well, the derivative of y is just y prime in the case that we're doing today, plus the second times the derivative of the first, which is 2x. Again, I kept the subtraction out front, so that's why I'm just doing positive 2x here, because eventually I'll have to distribute that subtraction anyway. You could keep that subtraction with the x squared if you wanted to. And then so that was first times derivative of second, plus second times derivative of first, plus derivative of 2x, which is just 2, equals 0. So another one where we have y prime in 2 spots. So I have 6y y prime minus x squared y prime. It's nice that those two are already by each other, so y primes. Distribute this negative, so this one I have a negative 2xy plus 2 equals 0. Now it's just like the previous one. Any terms without the y prime go over to the other side. Factor out the y prime, and then divide everything else across. So I have, I'm going to just maybe see if I can do that in one step here. Would it have been really hard to solve for y up here? Could you have solved for y up there? Not with the y squared and the y. Okay, you couldn't have gotten y by itself. So that's why implicit derivative comes into play. It's not like our very first one that we had where it was x, y equals 1. Okay, you're going to get into these ones where you're going to have to, there's no way you can get y by itself, so you have to do the implicit derivative. And you're still going to have y in your answer. So the big thing I do want you to know, because the next problems that we're going to do is going to involve a little bit of like the tangent line equations. I do want you to know they're not going to then ask you for y prime at 2. They have to give you a whole coordinate that they're going to ask you for. So if they then ask you for y prime at maybe like 2 comma 1, then you have an x and a y you can plug in. So at this point, they would not be able to just give you an x, they would have to give you an x and a y. So sometimes you see it like this when they ask you to plug it in. Sometimes they might write it like this, but they have like a little separator with a little 2 comma 1 here. Those are two different ways that they kind of show it. I don't know why they show this little divider, but okay, those are two different ways that if they ask you to now plug in a point at what is the slope of the tangent line, because that's what we're doing. Ultimately, the derivative is the slope of the tangent line. At 2, 1, well, you'll know what it is exactly at that point. So again, going forward, they're just going to have to give you a point if they ask you to plug in a number. So now this one, it says find the slope of the tangent line at 3, 2. So this one's a specific point. For xy plus 2x minus 5y equals 2. So I want you to try this one out. Another little product rule here again. This one then has to find the slope of the tangent line at 3, 2. We have to plug in 3 very nicely. Slope of the tangent line is asking you for the derivative. Y prime. If you think you're done with it, here's what I have up on the board. I think the biggest thing for that one is remembering the derivative of negative 5y. Doesn't mean negative 5, but you still have some pass y prime. So that's the biggest thing. A lot of times we do it when we're trying to do the derivative of y, but when we realize that it's just negative 5, we still have to attach the y prime. Okay? Raise your hand if you got to this step. Okay, maybe before I put this up here. Okay, so again, making sure with those y primes, putting those in there. What do I still have to do at the end? Plug in the points that they give us. So y prime at 3, 2. I get a negative 2 minus 2 over a 3 minus 5. So I get 2. So remember, this, you just found the slope of the tangent line. So it does not give you a nice equation like in the past we've had y equals and have been able to do y prime, do the derivative. Implicit derivative is still the same thing. Slope of the tangent line still means that at the point 3, 2, that is the slope of our y at that spot. Okay, so still means the same thing. We're just looking at doing implicit derivatives versus just normal derivatives with y equals. So knowing that, because I'm going to come back to this, Now, what would change when it asked you to find the equation of that tangent line? What would I have to do? So we did all the work already. So what if they then asked, okay, we got the slope, what do I do now to do the equation of the tangent line? Okay, what formula am I going to use? Point slope. Yep, y minus y. So y minus 2 equals my slope of 2, x minus 3. That would be a simple follow-up question that they might ask. After you find the slope, then they'll ask to find the equation of the tangent line. Don't have to do any extra work because we already found the slope there. And then what if they go and ask this one? Find the equation of the normal line. So still the same equation. What changes there? The slope, and I heard reciprocal and opposite. So negative, or if it was negative, positive. Okay, so the numbers, the 2 in the 0.32 still stays. This just becomes a negative 1/2 now. X minus 3. Negative 1/2. Remember, normal line, we just had that on that quiz. Opposite reciprocal slope for your tangent line. So good questions that they would follow up with, just knowing the idea of implicit derivative, but then being able to follow up with different types of equations. All right, the last one we're going to do is just one of these. I have 2 examples of these, but we'll do more second versions tomorrow. We have this find y double prime. We haven't done second derivatives in a while, other than talking about acceleration. So this one wants us to find y double prime, or d squared y over dx. How they'll show it. If they use dy over dx, they'll show that where the squaring is going to go. The idea of that's the second derivative. So you need to first find the first derivative, get y prime by itself, and then go and find the second derivative. So implicit is going to happen from the first derivative. The second derivative, what's going to happen is our, like you might have quotient rule. You might have something, if you had to divide, you might have to do a quotient rule here. So a lot of times first derivative is the implicit, second derivative is more of your derivative rules. So I have 3x squared plus 3y squared y prime equals 0. And just solve for y prime. And then we'll have to do the second derivative. But again, the second derivative won't be the implicit derivative since we'll already have y prime by itself. So I have a negative 3x squared equals a negative 3y squared y prime. Is that backwards? Divide by 3y squared, I get y prime to equal negative x squared over y squared. I get negative 3 over 3, which is just negative 1. Pause there for a second. Any questions on how I got the first derivative? Implicit derivative. Now they ask for the second derivative. Well, you don't have to go, all you have to do is go from here. My first derivative, well, we know then to find my second derivative, it's just going to be a little bit of a quotient. You're just doing the second derivative of your, or you're just doing the derivative, I should say, of your first derivative. So this is just a little quotient rule that you have here. Low d high. So we do still have to attach the y prime. So you do still have to attach that. It's just you don't have to go back to the way beginning and have to solve for y double prime and go straight there. So I had first or low d high less high d low. This is where I'll attach the y prime as well. So low d high less high d low. Draw the line. Low squared below. Y to the 4th. Y squared, and then I just squared it. So y to the 4th. Now, ultimately, in this second derivative, what you're going to see them do, especially if when you go to like homework and have to do the second derivative between today and Monday, they're going to plug the first derivative back in so that we don't have 3 different variables in there. So in this spot, they're going to plug in this negative x squared over y squared. So they're going to do that a lot of times, so then you still only have our x and our y as our variables. So I would have, if I want to maybe just reduce it a little bit, negative 2xy squared plus 2x squared y times negative x squared over y squared. All I'm doing right now is plugging in my y prime for my y prime. All over y to the fourth. So on second derivative, I would expect you to do that. Plug in your y prime. So then we still only are dealing with x's and y's. And a multiple choice, do you think they would end there?
No.
Multiple choice, they probably would reduce even further. Okay, because you could actually get one of these y's to cancel with this idea that it's on the bottom. Okay, so they'll try to reduce that even further with multiple choice. Yep.
One that was trying to do, like, the first, variable, like, construct, and the second one,
Yeah, so yeah, because if you went and solved for y, a little bit of cube root work, yes, you wouldn't. That one might just take longer just because you have a lot of cube root. But yes, ultimately you could. If you wanted to do solve for y first, the algebra, get y prime. Then the second, you would still have to make sure that you're adding that y prime. Yep, but you definitely could. So if it was like a simpler one, definitely do that. If it's something even like this, where cube root of what you'd have might still be a little bit more extensive, doing that implicit first and then doing the derivative after that, with still having that y prime in there. So again, I would accept it here, like on a quiz or a test. Multiple choice for AP would probably go even further with reducing that. So we will do one on, and your back of your book, if you ever check, so today's homework is numbers 1 through 15 odds. But if you check the back of the book, it will probably have the simplified version of like what a multiple choice would have. So they probably would simplify this one even further, so just an FYI of that. I do have the worked out solution, so if you work here in the next 10 minutes that you have left, I do have a worked out solution, so if you at least wanted to check to make sure you got to this step correct, you definitely can. Okay, because the back of the book will show the even more simplified version of it, but I would be okay if you at least got to that point in that. I have this up here. Maybe I'll put it up here right now. You have 10 minutes. The last 10 minutes you can work only 1 through 15 odds. Okay, so not that many problems, but they're all going to be implicit. So some of them involve a little bit more work, so make sure that you're showing that work for it.